Okay, linear programming level 2 now. Now we're going to step it up a little bit. Okay, so I have a picture right there. The training wheels are off. Okay. You will want to write down these steps to complete a linear programming problem. Okay, this is step 1. Identify the variables. Okay, like I said, these are all going to be word problems. Okay, so identify what variables, what's changing in my problem, what am I working with? Is it blankets? Is it CDs? Is it iPhones? Whatever. What am I working with? Step 2, then identify and write out your objective function. Okay, so in these ones, you need to create your own objective function. Number 3, you need to come up with the constraints. And so this will all tie back to number 1, where it say with a table. So we're going to make a table, and we'll be able to pull constraints from the table and the objective function from the table. Number 4, then, now we're at the step that we were at for that worksheet that we just did on those 4 problems. After we've done the first 3 steps, now we're at that same point where we can graph the constraints, shade in that feasible region, identify the vertices, plug in the vertices into our objective function, and then determine our conclusion. So now these steps 1, 2, and 3 were already done for you on that worksheet. Now you need to do steps 1, 2, and 3, come up with that information, to use that information to graph and come up with your conclusion. Once you do all that, you're successful and you can write away. Okay? So I'll give you a second to write that down. So we're not even into those guided notes yet. Okay, this is something in addition. The guided notes are 2 problems that we're going to work through. Okay, so again, the first 3 steps here are what's new. 4 through 7 is what you are already doing. But identifying those variables, creating the objective function, and then creating the constraints are the big pieces. You need to do that right to be able to get through the rest of it. Okay, and I'll put these slides on Schoology as well. So if you didn't get that whole list, just go back to Schoology, you can see it. Okay, so here, this is the first page. So the one that I hand wrote in there, profits, that's the side we're on. Okay, a group of students decides to sell blankets and pillows that they make in family living class for a fundraiser. Okay, so that's the first setup. So right now I can identify they're selling blankets and they're selling pillows, and so those are going to be my variables. Okay, and just to keep it simple, I'm going to say that's X and that's Y. So when it says identify the variables, what's changing, we're eventually going to get to, all right, if I sell so many blankets, I sell so many pillows, it's going to come out to be a number. Okay. Each blanket uses 4 yards of material and takes 1.5 hours to make. Each pillow uses 2 yards of material and takes 6 hours to make. The students have 80 yards of material and 60 hours to work. The blankets sell for $25 each. The pillows sell for $10 each. So all of this is in that paragraph there for your guided notes. All this information. There's a lot of numbers, as you can see, going on. It's not as simple as, oh, just identify the numbers. Those are going to be your equation. Now we got a bunch of stuff going on. Okay? The question, how many of each should they make to maximize the profits? Okay, so we have this whole big scenario going on. They're selling blankets and pillows. Each one has different constraints put on it, that it takes 2 yards and 1.5 hours to make a blanket, 2 yards and 6 hours to make a pillow. They have only 80 yards of material, 60 hours to work. The money is playing in there, so there's a whole bunch of stuff going on. Okay, so this is already written on your sheet, this setup. Okay, so the first thing, step one when we had that checklist was to make a table. Okay, so I know on here, so yards of material. So yards of material for my blanket, I had 4. For my pillows, I had 2. And my max number was 80. So 4 yards for each blanket, 2 yards for each pillow, and my max was going to be 80. Well, remember blankets, we identified that's my variable X. Pillows, I identified was my variable Y. If I add these two together, it has to be less than or equal to 80, because 80 is all I have to work with. So there in our table, we've created our first constraint. Because it's going to be 4 yards for each blanket. It's going to be 2 yards for each pillow. And the number of yards of material was 80. I have to be less than or equal to 80. Now, the time it takes, okay? So it takes, for a blanket, 1.5 hours per blanket. So I'm going to say 1.5x. For the pillow, it takes 6 hours, and so I'll say 6y. And the amount of time I have to work with is only 60 hours. So these added together has to be less than or equal to 60. All right, so I identified my variables. These are going to be my constraints that I'm working with. Now the profit, so the last statement in the profit, it said the blankets sell for $25 each. So that's $25 per blanket. And the pillows sell for $10 each. So that's $10 times Y. And there's no max profit that I'm going to have. Okay, I don't have an answer saying I want to achieve $150 in profit. There's nothing like that. This last line is my objective function because that's what I'm trying to optimize. How many of each should they make to maximize the profit? How many they make is from this. This is the objective function. Okay, so my objective function is 25x. So I'll say P for profit equals 25x plus 10y. Okay, so again, my blankets were X, my pillows were Y. The next step was constraints. So 4x plus 2y is less than or equal to 80. And I also have 1.5x plus 6y is less than or equal to 60. And I will have the constraint that x needs to be greater than 0. X represents blankets. I can't have a -2 blankets. So x is going to be greater than or equal to 0. And y is also greater than or equal to 0. Landon. Will you always have those two? So in a word problem like this, when you're dealing with, this case, blankets and pillows, we can't have negatives. So yes. So just pay attention to the context of the problem. If it was something potentially in like degrees Fahrenheit, we could have negatives. Okay, so just pay attention. But when it's physical objects like this, we can't have negatives. Okay, all right. So now we've identified our objective function. We've identified our constraints. This is where we're at on the worksheet. So this is the hardest part, is coming up with this. And we're going to do another one here in a minute for extra practice on it too. But let's continue on with this problem. So I need to graph these 4 constraints. So if I did it using my method of right there in standard form, so 4 times 0 plus 2y equals 80. Well, then I'm going to have y is 80 divided by 2, which is 40. So I know I'm going to have one y here at 40. It might be tough to see, but mine, that top one is at 40. You have a different graph that you can see a little bit better on yours. Okay, and then I'd also have, if I set y equal to 0, be 80. And so 4x equals 80. So then x would be 20. So that's going to cross here at 20. So this is my first function. Now for my second one, I would have 1.5 times 0 plus 6y equals 60. So therefore, y would be 10. I'm going to go here at 10. And the other one, 1.5x plus 6 times 0 equals 60. So 1.5x equals 60. If I did the division on that, I would end up with 40. So this one's going to cross way out here at 40. So I'll have a line. It's not very straight, but it's going to look like that. Okay, so next I went to, and there's a little bit better. I graphed it on Desmos too to give you better straight lines. Next thing I want to do is identify my vertices. Move these up. X greater than 0, y greater than 0. So my vertices. So I'm going to have a vertices here, 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 and here. This will be my shaded region, my feasible region. So I'm at 0, 10. I'm at 0, 0. I'm at, this one was 20, 0. Now this one here, we want to find that point there. That's not a nice one that's coming right in the middle of our grid. We can approximate that one a little bit, okay? Because it's going to give us a vertice, and we're going to test that point. If we're pretty close, we'll be able to see where we're at. So if I approximate this one, I might say this is like my x value. I took that down. That's like about 17. And then if I took this over, might be about 6. We'll try it there. Okay, and these are approximations, but we're gonna be close. All right, so my vertices are 0, 10, 0, 0, 17, 6, and 20, comma 0. How we doing? Is this making sense? Where we're at on all this? Just stop me if it doesn't make sense. Okay. All right, so we got our vertices. Next thing, and kind of got put behind there, but it's the values. So I actually have to test each one in my objective function. So I'm going to try each one. So P of each one. So 0, 0 is going to be 25 times 0 plus 10 times 0. I know that's going to get 0. P of 0, 10, 25 times 0 plus 10 times 10 is going to give me 100. P of 20, 0, 25 times 20 plus 10 times 0. What's 25 times 20? Be what? 25 times 20. 400. Okay, so that one's 400. And then my last one of 17 and 6 be 20 times 17 and 10 times 6. 20 times 17 plus. This one ends up being 400 as well, but again, we approximate a little bit. Math. That's right. As soon as you said that too. Yep, you're right. 500. I was jumping ahead of myself. Come on, Jake. You're making me look bad. What? Oh, did I? Oh, you gotta be smarter in what I'm saying. 500, thank you. All right, 25 times 20 is 500. There we go, that makes more sense, not 400. Okay, all right, so we've tested all our points. So now we can come to our conclusion and say that the point at 20, comma 0 would optimize our function. Okay, but what is that 20 times 0? What does that 20 by 0, what does that represent in terms of the original context of the problem of blankets versus pillows? Colin. Other way around. So 20 blankets and 0 pillows. Okay, so that 20 and 0 tells us to optimize, we only want to make 20 blankets and 0 pillows. Would be the optimal, factoring in the material needed, the hours that it's going to take to do it, and the cost of each one. So again, this is a lot of work to get to this final answer. There's a lot you have to do. Okay, let's do one more here for practice, and then I'm only going to give you one of these to do for homework, and then we're going to talk about it in class on Friday, and then we'll do a couple more in class together on Friday. Hopefully clear up any confusion, and then we'll take our test on it. Okay, all right, so another one. So this is exactly what you have there in your sheet. Baking a tray of corn muffins takes 4 cups of milk, 3 cups of wheat flour. Baking a tray of bran muffin takes 2 cups of milk and 3 cups of wheat flour. Okay, so I can identify my 2 variables. I'm working with corn muffins and I'm working with bran muffins. So I'm going to call X for corn muffins, Y for bran muffins. Okay. A baker has 16 cups of milk, 15 cups of wheat flour. He makes $3 per tray of corn muffins, $2 per tray of bran muffins. How many trays of each type should the baker make to maximize the profit? So this one is similar to the last one. We're going to create an objective function based on this profits. Once we have that objective function, that's where we're going to test our vertices in, and then we can determine from there. Okay. All right, so start with a table. I encourage you to start with a table every single time. That'll make things a lot easier. Okay, so this one I put profit on top. It doesn't matter what order you go in. If you like profit on bottom or you like profit on top, it doesn't matter. Okay, but it said in the setup that he makes $3 profit per tray of corn muffins. So 3x, because I labeled corn as my X, bran as my Y. Makes $3 per tray of corn, $2 per tray of bran. Right there, that's our objective function, 3x plus 2y. Now, for the milk one, okay, so we have to look at the milk. Baking a tray of bran muffin takes 2 cups of milk. So pay close attention here. This is 2 cups of milk for the bran. So this is 2y. And then the top sentence, it said 4 cups of milk for the corn. So that's 4x. And then the wheat, 3 cups for the corn. And for the bran, 3 cups of wheat for the bran. But we do have maximums for milk and wheat, because it says a baker has 16 cups of milk, so that's the most he's going to have, and 15 cups of the wheat. And this is less than or equal to, less than or equal to. I can't go over what I already have. Okay, so using that table, we were able to clearly identify our objective function. We could identify our constraints on there as well. So our objective function was that 3x plus 2y equals, I'll say P for profit. Our constraints are 3x is 4x plus 2y is less than or equal to 16. 3x plus 3y is less than or equal to 15. Corn and bran has to be, they're physical objects. We can't have any negatives. So we're going to say x has to be greater than or equal to 0, and y also has to be greater than or equal to 0. All right. I've jumped ahead a little bit. I already graphed these. So the graph on the right shows these two lines graphed, but you can find the intercepts on each one, and you can graph. And so my vertices are going to be here at 0, -5. It's going to be here at 3, 2, here at 4, 0, and here at 0, 0. And I want to see that you shade or clearly identify the feasible region that you're working with. So vertices 0, -5, 3, 2, 4, 0, and 0, 0. Now, to determine values, we're actually going to put these x and y values into the objective function. Okay, so we could do each one individually, and we're running short on time. I'll leave that to you. Plug each of those in and determine what value is going to be the maximum value, and then translate that to say, okay, that represents this many trays of bran muffins and this many trays of corn muffins. Maya. Speak up louder. I'm sorry, I can't hear you with your mask. Uh, 0.5. Thank you. Not negative. I don't know what I was thinking there. Thank you, Maya. Okay, so you got to test all of those, but then remember, your coordinate is not your final answer. You have to go back and say, okay, that represents this many trays of corn and this many trays of bran muffins. Okay, so I'm going to give you a worksheet now with word problems. There's 4 word problems on here. You only have to do the first one for Monday. Or I'm sorry, for Friday. Okay.